All right, welcome. You know that feeling when you see a massive GCSE math question and you just don't know where to even begin? Well, in this explainer, we're going to tackle one of those tricky multi-step problems and break it right down into simple, manageable pieces.
Okay, so here it is. This is the problem we're going to be tackling today. Question 13, and this is straight from a higher tier paper. I know, it looks a bit intimidating at first glance, right? But trust me, stick with me on this one. You'll see it's really just a few logical steps all stitched together.
So, here's our roadmap. We'll look at the cuboids, calculate their volumes, turn the problem into an equation, solve that quadratic, and then get our final answer. Simple as that. Let's get started.
All right, first things first, let's get to know the two main characters of our problem.
So on the left, you've got cuboid A, and on the right, cuboid B. Now the first thing you'll probably notice is that their dimensions, the length, width, and height, they're not just plain old numbers. They're actually algebraic expressions, and they all involve x. And that little x is going to be the key to cracking this whole thing.
Right, so if we're going to solve this, our first big job is to figure out an expression for the volume of each of these cuboids. Length times width times height. Let's get on with it.
Okay, then let's dive into the calculations. We'll kick things off with cuboid A and build out that volume expression. So finding the volume of cuboid A, it's pretty straightforward, right? We just multiply its three dimensions together: the length, the width, and the height. And that leaves us with these three brackets that we need to expand.
Okay, first step. Let's just focus on multiplying the first two brackets together. That's the 2x minus 1 and the x minus 1. Getting that done will simplify things down quite a bit.
And now we just take that result and multiply it by the last bracket, the x plus 2. And boom, there we have it. The full, completely expanded expression for the volume of cuboid A. Perfect.
Awesome. One down, one to go. Now we're going to do the exact same thing for cuboid B. Just multiply its three dimensions.
But wait a second. Look at this. We can actually spot a really neat shortcut here. See those first two brackets, the x minus 3 and the x plus 3? That is a classic difference of two squares. And that simplifies super cleanly to x squared minus 9. That just saved us a bunch of time.
So, with one last easy multiplication by 2x, we've got our final simplified volume for cuboid B. And there we are. We have our two key expressions. That's the heavy lifting done.
All right, so we've got our two expressions for the volumes. That's great. But what do we do with them? How do they connect? Well, to figure that out, we have to go back to the original question because it gives us the final, absolutely crucial piece of the puzzle.
Pay attention to this sentence right here. This is the golden ticket. It is the absolute key to the whole problem. This is the bit of information that allows us to connect the two volumes we just worked so hard to find.
So how do we translate that from English into math? It's simple, really. It just means volume A is the same as volume B plus 142. That's our equation. And now for the easy part. We just take those two big volume expressions we figured out earlier and plug them right into this equation. We're just substituting the algebra in. Let's see what happens. And just like that, we've built our equation. Now the fun really begins. The next step is to actually solve it and find out what x is.
Okay, whenever you have a big, messy equation like this, the first thing to do is look for anything you can simplify or get rid of. And what do you know? We have a 2x cubed term on both sides of the equation. So they just cancel each other out. How perfect is that?
And boom, just like that, what looked like a really scary cubic equation a second ago has turned into a much friendlier quadratic. And this is something we definitely know how to solve.
Now you know the drill with quadratics. To solve them, we've got to get it into that standard form. And that just means shuffling everything over to one side of the equation so the whole thing is equal to 0.
All right, time to factorize. We're hunting for two magic numbers. They need to multiply to give us negative 140, but at the same time, they need to add up to positive 13. So, after a little bit of thinking, you'll find those numbers are positive 20 and negative 7. And that gives us our two factored brackets.
Okay, so we've got our brackets, which means we have two potential answers for x. But hang on, this is a real-world geometry problem. Can both of them be right? Let's find out.
So for this whole equation to be true, one of those brackets has to be equal to 0. That's the only way it works. So either the x plus 20 bracket is 0, which would make x equal to negative 20, or the x minus 7 bracket is 0, which would mean x is 7. So we've got two possible values for x. But like I said,
This is a geometry problem. Does it make sense to have two answers? This is where we have to use some common sense. We have to check our answers against, physical reality. Let's just look back at cuboid B. One of its sides has a length of x minus 3. Now, if we try plugging in x equals negative 20, well, that would give us a length of minus 23 centimeters. And that's impossible, right? You literally can't have a negative length. But if we try x equals 7, all of the dimensions for both cuboids work out to be positive numbers. So x has to be 7. It's the only solution that actually makes sense in the real world. And there you have it. That's our final answer.